Has this ever happened to you? You were searching for street food online, but the results that search engines found were not what you expected. This comes to be the first problem. Not easy to find street food online. You scrolled on and scrolled on. Finally, you found a food truck. But you were disappointed because you didn't see many reviews. This comes to be the second problem. Not enough reviews to attract customers. Or you happen to try some good food from our food truck, and you came back to get some more the next day, but it was not there anymore. This comes to be the third problem. Food trucks change locations frequently. Suppose you found a popular street food vendor nearby. You were waiting and waiting in the line, and it was finally your turn, but you were told they were sold out. This comes to be the first problem. Easy for street food vendors to misjudge inventory and customer traffic. One day, a great street food business idea comes to your mind, and you were wondering, is there a website that I can go to get help? Yes, this is where our project, StreetFoodLove, can help. StreetFoodLove is an application that provides instructions and tips for business entrepreneurs to start up street food businesses, allow food vendors to create vendor pages to present the real-time locations, business hours, logos, pictures, menus, ratings, and unbiased reviews to the customers. Food vendors can subscribe to our service to have a dashboard on their vendor account page with visualized statistic data graphs, such as a timeline of average rating increase or decrease, how many new reviews were generated within this month, what are the 5 popular search inquiries from customers within this week, and so on. Next, let's Colin and Sylvia introduce our user experience and phototype demonstrations.
When the user visits the site, they will be greeted by a big map of the local area along with the StreetFoodLove logo on the top left, a search bar in the middle, and buttons to log in and sign up for accounts on the right. Clicking on the StreetFoodLove logo will lead users back to this current page, no matter where you are on the site. The map, which can zoom in and out, will be where the current locations of the vendors that are signed up for StreetFoodLove are shown. Users will be able to type the name of the preferred vendor in the search box, provided in the header. The results of that search will display in a sidebar on the left side of the map, and also on the map itself with an icon. Search results can also be filtered with the filtering options on the left sidebar. Clicking on this icon will display a pop-up, which contains the basic information of the current vendor, including name, rating, and a sample review. Clicking on the name of the vendor in the pop-up will lead to the official vendor page of that vendor on StreetFoodLove. On the official vendor page, there will be 4 cards arranged in a 2x2 format, which will display all of the essential information about that vendor, such as the contact and address. The map option in the bottom right-hand column will lead to Google Maps, where the user can find the best route to the specified food vendor. For the sign-up functionality, there will be 2 different approaches, depending on the account type that the user wants to make. Clicking on the sign up button on the top right-hand corner will lead the user to the account type selection page. If the user clicks on the customer type account, then they will be taken to the customer account sign up form. If the user clicks on the vendor account type, then they will be taken to the vendor sign up form. Vendors will have to fill out an extra form with details about the business they want to run, in addition to the same form that user type accounts will have to fill out. Here is a quick summary of the functions that are going to be implemented in your app. The list is ordered by importance priority. If you are interested to know more information about any of the functions, you are welcome to ask for more details in the Q&A section. Now I will hand it off to Sylvia to talk about the prototype demonstration.
Once a customer has created an account, the user can submit a review on the vendor's page. Before writing a review, the user needs to log in by clicking the bright orange login button. After entering login and password information, we click on the green login. We scroll down and click on Write Review. A star rating review and text box will appear. We can leave a 1 to 5 star review by selecting the last star of the desired rating. As you can see, all previous stars will light up automatically. In the box, we have the option to leave a detailed message based on our experience. When finished, we click the Submit Review, and our feedback will be saved below in incoming order, meaning oldest review will move down and the newest will be listed on top. Once implemented, instead of these black blobs, we will see the user's profile pictures, and the stars will be highlighted based on the user's original selections. Up next, Makoto will give us an overview of the technology, systems, and testing part.
To explain how it all works, let's go back to that demo. But this time, I will take you behind the scenes and show you step by step how it all works. We structured our service based on the 3-tier architecture. You might remember the layers being called the presentation and business logic layers. Here, I refer to them as the front end and back end. Inside those layers, we further subdivide them at the source code level. Let's start from the top. The user goes to a vendor page at the URL vendors/vendor ID. The React framework renders all the components on the vendor page and initiates an action. An action changes the application state and may have side effects, such as to trigger an API call. The action we just triggered looks like this. It might look complicated, but all it's really saying is, user wants the vendor page. A reducer sees that action and triggers an API call. It also changes the application state to indicate that our app is busy, which the UI could show with a spinning wheel. We just passed the state and actions layer, and now we are here at the API abstraction. As the name suggests, the API abstraction is just a wrapper around the API to hide the details. This function call, vendors, is converted into an HTTP request. Get vendors, blah blah blah. Now, we have crossed over to the backend layer. The API is the interface for the backend. It's what allows the front end and the backend to communicate. For any password-protected resources, this is where authentication is handled. Our RESTful API is documented in an Open API specification. Scrolling down our documentation, we can see that the vendor's resource is here. Inside the backend code, which is written in Go, the API request calls the vendor method, with vendor ID as the parameter. The application logic layer is what I like to refer to as where the magic happens, because that layer's responsibility is to transform API calls into database queries. If any third-party services are required for a resource, they are called from here. The database abstraction layer hides the database details. To look up a vendor, we use a MySQL query like this. We're finally at the database where all content data is stored. The vendor data is going to get sent right back up, and the view will render the vendor page for the user. So I just talked about how it works, but where exactly is it taking place? What services do we use? We will be using various AWS services. The backend will be running on an EC2 instance, the database will be stored in RDS, images will be stored in S3, and OpenSearch will be used for our search engine. The files for the front-end app will be hosted on GitHub pages. Finally, OpenStreetMap will provide the map tile images for our map. Let's talk about testing. We will add unit tests wherever we can to test small units of code. The interaction between various layers will be validated with integration tests. Integration tests will use a local database and API calls will be simulated. Its actual responses will be compared with expected responses. We looked at how our web app will be divided into 8 different layers and run on various services. This separation of concerns allows us to divide the whole architecture into small responsibilities. When we implement a new feature, we can divide that feature into different layers and develop one layer at a time.
With the help of StreetFoodLove application, it will be easy for customers to discover new street food vendors on the map and have access to unbiased reviews, which is designed to solve the first and second problem. On the other hand, with providing a function to keep track of food truck locations, it will help build a stronger link between customers and their favorite mobile food vendors, which is designed to solve the third problem. Meanwhile, with providing tips and data analysis results to food vendors, it will help them predict customer traffic and make a better plan on inventory, which is designed to solve the first problem. We will launch StreetFoodLove as a web app first and continue developing it to be a mobile app as well. In the first milestone, we have implemented a basic web app with vendor page, login, customer review functions ready. In the next milestones, we are going to implement more elegant features such as map, searching, filtering, sorting, and location tracking, and so on. After we finish all the features that we have planned for the StreetFoodLove web app, we are going to develop the corresponding mobile app with some specific functions such as sharing to social media and push notification. We believe that StreetFoodLove will build a community that benefits both the customers and street food vendors in the future. Our team has a great passion on this project, and we have searched a lot of documents and websites. Let me give a big thank you to Professor Lee. Thank you, Professor Lee, for your great suggestions and guidance. Let's keep our passion and continue doing a great job in the coming quarters. Thank you for watching and have a great day.